Hello, all. I'd like to introduce Dr. Erika Rosenberg. Erika is going to be delivering a lecture on her work in FACS, which has been spans over 30 years, and she's a protege of the, the creator of this, Dr. Paul Ekman.
Thank you, everybody, for coming. I'm really happy to be here with you. I'm here to talk to you about FACS, the facial action coding system, to give you not really going to talk about my research per se, but rather talk to you about FACS, let you know what the facial action coding system is, give you a basic sense of it, because I know a lot of you who've come to this business of digital effects know a little bit about FACS. Some of you know a lot about FACS, and there's a lot of misunderstanding. So I'm going to give you a sense of what it is and hope that you walk away from this talk with an understanding of what the AU or action unit is. Many people in your field talk about AUs, have made use of AUs. That's sort of the elemental piece of FACS. I want to give you a sense of what that is. Give you also an appreciation for what FACS can do and what it can't do. Then take sort of a deep dive, a brief deep dive into what it's like to actually use it as it was intended to be used. That is, to use FACS to describe moving faces. Then we will, when I'm done with all that FACS overview part, I'm going to take a moment to look at what's considered really state of the art in digital effects and give a FACS-based critique of that, both appreciating how far we've come and also seeing what work is yet to be done. Before I get into this overview of FACS to give you an appreciation of it, I'd like to take a second and really look at the progress that has been made in digital animation or digital human faces. I am not a historian of computer effects or digital effects or digital facial creation, but in fact, my first foray into this began in 2004 when I was invited to give a talk at a conference on virtual humans. So at that point, people were already familiar with FACS, but I was digging around online looking for old CGI, and I came across this on YouTube. Fred Park, a computer scientist from the University of Utah, had done some of this original work. Check out this, if you haven't seen it before, as an early digital human face. This is pretty impressive to me, actually, because some of the faces that I saw back in 2004 didn't show, with a smile, the movement of the cheeks that's more authentic. So this is a pretty impressive, even though it's crude, a pretty impressive example of early facial animation. I really don't know how this was done, and if anybody is an expert on it, I'd love to hear more about it. Any historians on computer effects, but this is, this was sort of state of the art in, let me move it ahead and give a little pause here. State of the art in the mid 20th century, shall we say. Then let's look at what we've got today.
I am a metahuman, the next generation of digital human powered by Unreal Engine.
So some of you have probably seen the MetaHuman creator that Epic Games has created. This has been recently brought to my attention. This is a very, very impressive digital human. And judging from how a lot of people react to these digital heads and moving faces, they're very convincing. But even still, there are ways they could be improved. So I'm going to take a look at a couple MetaHuman heads and another couple examples of state-of-the-art digital humans later on in the talk. But this sort of spans the development of digital faces. And I don't know when along the way FACS came into this equation, but I do know that it has informed the how these faces are created. The first thing that you need to know about FACS is facial action coding system. So it is a system for describing facial action. Action is very important here, especially when it comes to learning FACS, because I know from people who work in the digital effects field who've created digital humans that there's a tendency to focus on shapes. Shapes are very important. They're useful heuristics, but FACS is really about coding the action of the facial musculature. I came to FACS in 1988 when I was a new graduate student at the University of California, San Francisco, where I came to study human emotion. and the effects of emotion on health. And I was very lucky to come into contact my first year there with Paul Ekman, who is the creator of FACS. Now, Paul Ekman had made a career out of studying the face. He had done some pivotal work with his colleague Wally Friesen in the late 1960s that was really groundbreaking studies on the recognition of facial expressions of emotion around the world that ended up being the springboard for their work on measuring facial behavior to learn about emotion. So one of the things that you have to know when you come to FACS is that it was not created for the digital arts. It was created to measure observable facial behavior. In their interest in studying human emotion, Ekman and Friesen took a very thorough approach. They didn't want to just code the faces they thought were emotions. They wanted to be very, very thorough and unbiased and code everything they saw happening on the face to be totally objective. And because of that, FACS is comprehensive. It measures all observable facial behavior. And in an effort to measure all observable facial behavior, they decided they would rely on what was driving behavior, that is, the facial anatomy. So FACS is anatomically based. It is based on the human facial musculature. The elemental units are based on the musculature, and I will talk about that in the next few minutes. But key to remembering that is that the FACS is a behavioral measurement system. It is designed to decode faces, not to direct them. But because FACS offers a taxonomy of facial actions, somewhere along the line, some clever person realized it could be adopted by people who are creating virtual humans to offer very anatomically specific directions for guiding facial movement. Okay, so the cornerstone of FACS is the AU. You might have heard of AU. AU is the acronym for action unit. It is the elemental unit of FACS. Each AU, this is a definition of what an AU is, corresponds to the observable effects on the face of underlying muscular contraction. An AU then is a unit of behavior. And just to make this point in the second bullet point, AU is not a muscle. I think even within the behavioral sciences, some people treat AUs as if they're muscles. You can look to, and we will look to, the underlying muscles behind every AU, but the AU is a unit of behavior. So that if I contract this muscle right here, which is zygomaticus major, and it lifts my lip corners up, that's action unit 12. Now we recognize that as a smile, but that's action unit 12. And when action unit 12 occurs, there are a number of things that happen to my face. Not only do my lip corners go up, you see that my cheeks are lifted. It can create a prominence here, which can deepen my infraorbital furrow, stretches out the lips, etc. There are a number of things that happen with action unit 12. So an AU is not a muscle, it is the action of a muscle or the observed action of a muscle. There is pretty close to a one-to-one relationship between each AU and each facial muscle, but it's not exact. I'll show you some exceptions in a moment. One other thing to say is that each AU is designated by a number that's fairly arbitrary, although I should give a little hat tip to Scandinavian researcher from the mid-20th century, Hjortso, who was one of the first who suggested numbering the musculature for behavioral analysis. Ekman and Friesen really expanded that and developed it much further in FACS. Each AU, which has a number, is scored on a 5-point scale. So if you ever see a letter appearing with a number like an A, B, C, D, or E, that is considered an intensity scale or a magnitude of how strong that action unit is. All right, so those are the basics on what an AU is, what it's not exactly. It's not identifying a muscle, it's the action of a muscle. And you might hear people talk about coding. I might refer to coding or scoring with FACS. And FACS scoring or coding is what happens when somebody who's trained in the system describes facial expressions in terms of the AUs that comprise it. And I will give a demonstration on how that's done. So this is one picture. There are a number of wonderful pictures of the facial musculature online, and this is one I grabbed and used in my teaching. But this gives you a sense of the complexity of the human face. The human face is remarkably complex. The musculature is unlike anywhere else in the body. Most places in the body, muscles, at least striated muscle like the facial muscles, the skeletal muscles are for moving bones around. On the face, there's really only one bone that moves, the jawbone, and all the other muscles are connected to other muscles or to the skin, and therefore making different expressions, for lack of a better way of talking about it, that's used primarily for communication. The face also plays a role in eating and speaking communication and nonverbal communication. So looking at this diagram, you see in black the Latin names for the musculature, and in red the numbers that correspond. This is not all the facial actions, but this is the ones depicted on this diagram. And you'll see there's pretty much a one-to-one correspondence between a muscle group and an AU. So, zygomatic major, zygomaticus major, which I just mentioned before, you see right here, that's action unit 12. This strand alongside it, zygomaticus minor, is action unit 11. So for many muscles, there's one AU, but there are some cases where you have a muscle group here, like levator labii superioris. There's a group of fibers around the nose, these right here in particular, that are involved in two different actions, action units 9 and 10. The brow, frontalis or occipitofrontalis, is a large set of muscles, but the inner portion and the outer portion can move separately. So there's two separate AUs. By contrast, you can have an AU like AU4, which brings the brows down and together, and I'm demonstrating that right now. Action unit 4 involves 3 sets of fibers. You have corrugator supercilii, which brings the brows together, procerus, which brings them down, and another set of fibers is not actually on this diagram, which is depressor supercilii. But a FACS coder, just to go back, because we learn the action units and what they look like, if I look at a face like this, I see this, that she's tightening her eyelids and lifting them up with action unit 7. 12 is the action of zygomatic, which lifts the lip corners in a smile. Action unit 10 reflects that there's a little bit of her lifting up of her nose, and it's also evident in the lifting of the upper lip. That's why I have a 10B there. And the face is not straight on, it's slightly turned to the right. FACS, in addition to describing the musculature, it has a very crude system for designating any head or eye deviations from neutral. I want to show you a couple cases of the independent movement of one set of muscles. I made the point here, just to show you this diagram again real quickly, that frontalis has 2 AUs associated with it. So I am going to show you a series of videos. This is actually Thomas Turkeldson, who's a former FACS student of mine and working with me on a lot of FACS research and teaching right now. I want to show you here, in this first video here, he's demonstrating AU1, which lifts just the inner portion of frontalis. And you see here the brows have been lifted up from, if you go back to where they were, they've been lifted up from just into the center portion. And that's evidenced by these folds here, right in the middle of the brow. The folds in the brow are what happen when the medial or the middle portion of frontalis contracts. In FACS, we look a lot at things like furrows as signs for action. And it's important, I really emphasize this with my students, to know what a furrow is, what causes a furrow. So these lines in the brow, what causes them? Well, if frontalis is contracting this way, contraction means that the fibers get shorter, right? So what's happening here, the inner fibers, the medial portions, inner I mean close to the middle of the face, the medial portions of frontalis are shortening, and the skin is in its pathway. It's a sheet. Think of the skin as a sheet that is in the way of the contracting muscles. So it just folds up. That's why we get these little furrows here. So that's one, which is the inner portion of frontalis. And here we see what happens when the outer portion, frontalis pars lateralis, is contracted. You see the outer portions of the brow lift. You see these folds occurring just on the sides, not so much in the middle. You might have some trace wrinkles in the middle that are just a function of what someone might have on their head. When you're coding with FACS, you have to pay attention to change from the non-contracted muscular state, so that if people have surface lines or wrinkles that look like the folds that occur with action units, you have to make sure you account for that and only say the action unit created those wrinkles if they increase or deepen. So we have the inner portion of frontalis on 1, the outer portion of frontalis on 2, and here we have action unit 1 plus 2. You see the whole brow is lifted, and as a function of that, the lines go across the whole brow. So that's just a little demo of how one muscle, frontalis, different regions of it can act and have 2 different action units. I'm going to demonstrate action unit 4, which it brings the brows down and together. So my brows are being brought down and together like this. That's one action unit 4, but involves 3 different muscle groups. As I was pointing out on the diagram before, it involves corrugator, which corrugator itself, when corrugator contracts right here, it actually brings the brows together. And procerus, which is a strand of fibers here, and depressor supercilii, which is here, brings the brows down. So 4 is one AU that captures the brows being brought down and together. And that has 3 muscles. So these 2 examples that I've been giving you, frontalis, one muscle having 2 actions, and 4, one action having 3 muscles, shows you how FACS is not just a one-to-one relationship between the muscles and the AUs, but it's pretty close. And I should say that one of the advances in FACS is we are probably going to start separating some of the components of AU4 into more than one action. But currently the published manual does not do that. So I would like to give you a brief exposure to what it's like to actually learn FACS. Because the thing about FACS is, and the thing about FACS in the digital arts is, my experience is that a lot of people have come to it piecemeal. They've heard about it, they've maybe originally when people first came across the manual, they saw this, written description of the AUs and they read about it and they thought, wonderful, we can use this in our work. But to learn FACS, you really need to learn all the AUs. You need to recognize all the AUs, learn to recognize them. That means if you're given a face and not told what's there, you can actually accurately say which action units are producing any expression there. So that involves learning to recognize the AUs singly, that is when they occur alone, or in combination. In combination means with other actions. So I had been demonstrating to you earlier, action unit 4, and I'd shown you the video of Thomas doing 1 plus 2. Well, you can combine all of those into 1 plus 2 plus 4. So if I do this, a FACS coder would be able to say every AU involved in it. So how do you learn that? It involves self-study. Probably more than anything. The manual was originally designed to be a self-instructional tool. I'll give you a peek at the manual in a little bit. But if you've ever seen the FACS manual, it is a very detailed document, not very user-friendly. When I first learned FACS in 1988, Paul Ekman handed me a binder and a VHS cassette and said, learn this. It didn't matter that I was studying with the creator of FACS. They designed the system to be self-instructional. So you work with instructions and little video samples and pictures to learn how to code. There's also classes. I teach them, and there are other people offering things online too. But just so you know, it takes a lot of work. And if you're doing self-study, it can take up to 100 hours. Classes are a little bit more efficient, but it's a lot of work, and let me demonstrate why. These are just some cover shots. This is the original manual in 1978. This is currently the only official manual that's out there, published in 2002. Joe Hager joined the team to help digitize it and put it online. And while it might seem, or make it digital, it might still seem very crude if you've engaged with it, it was a huge improvement. And there were some changes in the content between 78 and 2002. I'm currently working on the new manual. So that is due out in 2024. Stay tuned. All right, so how do you learn an action unit? Because FACS learning involves learning all the action units. The first thing that you do is learn the relevant muscles behind the action units. And this is something I don't think was emphasized enough even in the current manual. And I put really a lot of emphasis on in my teaching, because the more you understand the muscles, where they originate and where they attach and how they move, the better you understand how it looks from the outside. So when I was making the point earlier that AUs are not muscles, that was not to diminish the importance of understanding the muscles, because if you ultimately go back to look to where the muscles are and how they move, it's going to make a huge difference in your learning of the action units. Then you go through learning what are called appearance changes. That is, when this action occurs, what does it look like? I'm going to give you an example shortly. So you learn how that action moves. You learn to look for features on the face that change, whether brows are lifted or not, or brought down, or whether furrows occur. So if I'm doing action unit 9, which is the nose wrinkler, you learn about the wrinkles, you learn about this nasolabial furrow, you learn that the upper lip is lifted, etc. So you learn all these ways it looks and what it does. Then you study examples, both video and still images. Another important point of learning an AU is how to perform it. Practicing the AUs, even if, many people are not very good at this. Some people are better than others. When people engage in learning FACS, when I teach FACS, I say no matter where you are, when you start this process, you're going to improve at posing. Now, learning how to pose, it's helpful for a lot of reasons. It, first of all, helps your learning. We know from research in psychological science that the more modalities with which you learn something, the better you learn it. So if you're reading about it and you're watching videos and you're moving your face, and so you get that motoric knowledge, you get a much deeper understanding. And for people in your line of work, if you really know how to pose it, that helps for scanning purposes. Then what's also super important, and I say this in my training now, even though when I first started training people in FACS, I was mainly training people in the behavioral sciences, because that's the tradition from which it emerged. But over time, more and more my students are people in the digital arts who might not be coding at all, and coding meaning using FACS to score action units. They might not be doing that in their work at any point, but the process of learning to code gives you a depth of understanding about action units that's hard to get anywhere else. So learning to code is learning to know when an AU is there and when it's not, because there are some action units that look really similar to one another, especially if your way of approaching the face and facial change is in terms of shapes. So I am now going to give a little brief dive into learning two different AUs, two AUs that are different but create similar shapes. Let's start with Action Unit 15. Action Unit 15 is the lip corner depressor. Now, every AU has a verbal name when you encounter it in the manual. It's a description of what the action is. So lip corner depressor means that AU 15 lowers the lip corners, and I'm demonstrating that now. That's AU 15. Now, on the diagram that you see here, I have entered, you see highlighted in red the muscle fibers of the underlying muscle of AU 15, which is depressor anguli oris. It's also known as triangularis. There are a number of Latin names, number of muscles that have more than one Latin name. The triangularis is obvious from the shape of the muscle. At any rate, you'll see here on this diagram that I labeled where the origin of the muscle is. Now, for those of you who have a familiarity with anatomy, you may know that muscles always move toward their origin. So when triangularis contracts, the movement is this way, if you see where my cursor is going, toward the origin, which describes what happens with action unit 15. The lip corners are brought down, as I'm demonstrating. So you learn that this is the muscle and this is the action. I'm going to show you next what a page, this is actually a page from the FACS manual listing the appearance changes due to action unit 15. This is where the core of AU understanding comes from. This is the heart of it, if you will. What does it look like? What does it do? Well, it pulls the lip corners down. That's the most simple statement of the movement, meaning you can see a quick movement. All you need to do is simply see a quick flash of those lip corners going down, and you know a 15 occurred. Action unit 15. There's a little stretching on this part of the lip. You get these folds here. These folds are important. Remember what I said about the folds or furrows in the skin? That's because this muscle, the triangularis, is right here and it's contracting. And remember, if you looked at the picture of triangularis, it's kind of curved a little bit. And you'll see that when these contract, they actually go this way. You'll also notice, just as a gestalt impression of the face with 15, is it creates this kind of long, thin face. Now, why does the face look long? Oh, incidentally, I've found, in English, long face refers to a sad face. And I've found from teaching all over the world that I've encountered at least 10 languages where the phrase long face refers to a sad face. And I think that's very interesting. Why do we, that's because AU15 is a lower face component of the sad expression. So this perception of it looking longer, it's not really longer, right? Why does it look longer? Well, when we process faces, we look at key feature points, and the distance between the eyes and the lip corners is actually more when I do a 15. It's here versus here. Notice with 15 that the appearance of the shape of the mouth is an inverted U. And that happens because the middle of the mouth stays right here and the corners come down. You can contrast that with the next AU we're going to learn, which is the chin raiser, AU17, because it can create the same kind of shape for a totally different reason. AU17 uses the mentalis muscle, which is a muscle inside the chin, and the origin of mentalis is right underneath the lip here, so that when it contracts, the movement is upward, not downward. With 15, it's a downward movement. With 17, it's an upward movement. And it lifts the chin boss and the rest of the chin. So the direction of movement's always toward the origin. It's going this way. If you look at the appearance changes of 17, and again, this is taken right out of the FACS manual, you'll see that 17, I'm going to revise this language. It says pushes the chin boss upward. Muscles never push. Muscles can only pull. So it pulls the chin boss upward, pulls the lower lip upward, and sort of the hallmark sign of 17 is this puckering that happens as the chin boss flattens. You may get a flat, dimply look, or you might just get some dents. It varies person to person, but there's always some kind of dimpling in the chin. And it can create the inverted U appearance to the mouth as drawn there. In this case, though, with 17, the inverted U shape is because the middle's coming up. The middle of the lip line is coming up. With 15, which we showed before, the lip corners are coming down. So anatomically in different directions, but they both create this shape. Another thing we see with 17 is that if the action is strong enough and the lips are moist enough, you will get kind of a pout. The lower lip will protrude a little bit. So that's AU17. Here's 15 again. Here's 17. Notice this area is relaxed. The lower lip is coming up, the chin is pulled up, there's dimpling. You can get bulging down here, but it's not the same as what happens with 15. So I just did a little 17 with it. You can get the combination of 15, 17, which is very common. Notice, so here's a 17 without a 15. And now I'm going to add the 15. Now I'm just going to step out of the coding for a second, because so that was a little not coding, but learning. That was a little microscopic look, or more detailed look at what's involved in learning action units. We just looked at some of the appearance changes. We didn't go through coding examples and posing and all that, but the level of detail is really important. That you have to know in order to accurately code, which means take any face. I mean, an experienced FACS coder should be able to look at any facial expression and tell you the AUs that are comprising it. And conversely, they should also be able to see a list of AUs on a page, a string of AUs, and be able to see what that face looks like in their mind. So stepping out of that level of detail, when do we see 15, 17, or the combination of 15, 17. This is just, I mean, we could spend a whole separate lecture on the displays of the AUs and emotion and non-emotion and the ways in which they're used, but I'm just going to highlight a few right now. And 15 and 17 are both action units that occur with sadness. 17 too. In fact, 17 is a very difficult muscle to voluntarily control. Sometimes people who are like, they have their composure, they think they really have it together. You might see just a little quivering of the chin boss if they're sad or upset. So we see it with sadness. We also see it in a nonverbal display that's not an emotional display called a facial shrug. I'll show you what that looks like. And both of these AUs are sometimes used to control the intensity of other lower face actions, in particular smiles, to try to diminish the importance of smiles, which is something that we sometimes see in the concealment or management of emotion. This baby that's probably getting close to crying. I'm not even coding his upper face. I will, that's a 1+4. And baby faces are fascinating because their skin is different. They don't get the folds that we do. They have subcutaneous fat pads. And when you want to code their face, you can actually see the muscles themselves through the skin. But right now, I could get lost in that. This face is fascinating. I'm going to not go into too much detail about other things, but let's look at the lower face. There's the 15, the lip corners are pulled down and the chin boss is pulled up, and we got a high degree of the lower lip protrusion and pouting. And this is a picture of yours truly several years ago. That's me with just displaying for a stimulus set, a sad display. And you see the 15 lip corners pulled down, the bulges here, and a little 17. Now, if I were actually to code this face for reals, right, I would need a reference. First of all, it's best to be coding a video so you can watch change from neutral. But at the very least, if I'm coding a still frame, I need a frame of this person in neutral so that I can see the change. FACS is about finding out what movement occurred, and neutral, the neutral face, is like this, sort of the unmoving face. So these are two sad displays. This is a facial shrug. This is, I think Bill Clinton was probably the public figure I've seen do this gesture the most. And why do we mean by a facial shrug? It's sort of like whatever. And it's used conversationally, emblematically to mean kind of an expression of doubt, I don't know, whatever. Here he's also showing some signs of smiling. There's some action unit 12 in here. This is where FACS helps you out a lot. People, you can see, I know from what his cheeks are doing and the angle of his nasolabial furrow that zygomaticus is major is contracted here as well. He's also got his brow lifted, 1 and 2, and action unit 7, possibly some 6, tightening the eyelids. But the facial shrug is what we're seeing down here, the 15-17 combination. Here's an example of AU 17 being used as a lower face control. 17, dimpling the chin boss. He's also got other AUs here. He's pressing his lips together with action unit 24. And there also looks to be a sign of action unit 9. This is the disgraced congressperson, Andrew Weiner, who had been exposed of, sexual misconduct. And here he's, I actually know this frame is taken from a press conference where he was trying not to cry. And a lot of people manage emotion in the lower face using 17 and 24, which I didn't mention here, to press the lips together. Okay, and then this guy is one of the fascinating things about Donald Trump's face is this is his typical smile. His typical smile has a high degree of action unit 17 in it. And so 17 has this ability to flatten out the smile by pushing up in the middle. So if you can see me on screen and I'm doing a 12 and I add a 17, see how the lip line just kind of flattens out? And we know from research, laboratory and outside of laboratory research on self-conscious emotion and emotional management, that people often use action units like 17 and 15 to diminish a smile. Donald Trump, most of the time, smiles this way. We also notice that people use 15 to control their smiles, and this is the actress Lena Headey, Cersei Lannister to many of us. I have noticed in many pictures of her that she uses a 15 with her 12, and you notice it by the lip corners, that compared to a smile without 15, she brings the lip corners down. And this is 15 is one of those AUs that people do to manage smiles, to control smiles. Again, I'm not getting into the reasons why, but it is one of those smile management behaviors that occurs in self-conscious behavior. So I'm just giving you an idea of when these things work. And also, I have other AUs. I'm just to let you know what I coded here. The 6 and 7 are coding the contraction of orbicularis oculi around her eye. So the 7 shows the tensing of the lower eyelid. The 6 is contracting here, these outer rings of orbicularis oculi, creating crow's feet and lifting the upper part of the cheek, which is the hallmark actually of a felt smile. She's also lifting up her upper lip a little bit, which is what AU10 is. And the 12 is the zygomaticus smile muscle, and 15, as you learned, is the action of depressor anguli oris, bringing the lip corners down. I would like to give you a glimpse of how a FACS coder works, like what's involved in FACS coding, because this is my friend Liz who posed for some photos for me. And here, if you're going to code a still photograph, or a single frame, you need to have a reference of their neutral face so that you can take into account where the features are, whether they have any surface lines or wrinkles that are going to mislead you about action. And here I can look at, she did a great job of putting on a lot of action units for me. So how would I go about coding this? I'm just going to verbalize it quickly aloud. But one thing I should say, that when a FACS coder does code, you systematically do the lower face and upper face. You do the lower face before the upper face. And the reason for that is there are more action units of the lower face that can bias how you read the upper face, because they can push up on the skin and affect how, if I go like this, you see the bagging of skin under the eyes. You need to know that that is happening before you go in to code the upper face, which might look at the bagging as a cue to contraction around the eyes. So we do the lower face first, then the upper face, and then we write the string together. So I'll just go in and tell you what I see looking at her lower face. The first thing that speaks to me real fast is what's happened to her chin. That's a classic 17 chin boss wrinkling. The chin has been, the chin boss has been lifted up. Now we see an inverted U appearance to her lip, and some of that has come from the 17 for sure. So this is a 17, but I know from the bulges there and the direction of her lip that her lip corners have been pulled down in addition to the chin boss being pulled up. Also, if she was just doing a 15, 17, she wouldn't have this shape to her upper lip. It would be more like that, relaxed. The upper lip just kind of gets displaced. But instead, we look at her upper lip and it's kind of bent, which indicates that something is lifting on the upper lip. And certainly something is pulling upward and creating the nasolabial furrow here. And indeed, these little wrinkles and the change in where her nose is, that has been lifted upward, and the nostril wings are lifted upward, and the shape and the depth of this nasolabial furrow indicates that she's done action unit 9, which is the nose wrinkler, like this. And we see, so far I have a 9, 15, and 17. However, when I look at the left side of her face, and a FACS coder, when you use left and right, if an AU is asymmetrical or unilateral only on one side, we designate which side, and that side is done on anatomical terms of the head you're coding. So that even though this is on the left side of your screen, this is my right side, right? So this is Liz's right side and this is Liz's left side. And on Liz's left side, I see that her nasolabial furrow is bent a little bit. And on the right, it's not, which means something's pulling probably obliquely here, which would, the best candidate for that is action unit 11, which is zygomaticus minor. It lies obliquely right on top of zygomaticus major. So I'd say that she has an 11 on the left side. She has a 9 and an L11, 15, 17. I think that captures the lower face. And then the upper face, clearly a lot's going on. We can look at her brow first of all and notice that we see these furrows here that weren't there in neutral. Those furrows are a sign of corrugator contraction, as is this little dent here. And that line here, corrugator is an oblique muscle. When it contracts, it does this. These little dents and bulges are really revealing, as the puckering above the eyebrow. Those are all signs of corrugator contraction. So we have evidence that action unit 4 has been contracted. I'm also looking at her eyes. Now she is looking down, which is going to reveal more sclera above her eye. But I think she also has action unit 5 here. Action unit 5 lifts the eyelid. So if you look at me for a minute, I'm just going to do 5. That's lifting the eyelid, exposing more of the eye, including some sclera, the whites of the eye. Now Liz has very heavy lidded eyes in neutral. Her eyelid goes over her iris, almost halfway in neutral here, where you see a lot more of the white of the eye. Now this is biased by her iris being pointed down because she's looking down, but I can tell she's lifted her lid from the eyelid itself. Look here, compared to here, it has lifted up. So I'm going to go ahead and code a 5. This is my codes. The D, C, and etc. are the intensity. The L indicates left side only. And these I didn't mention, the 61 and the 64. I mentioned that FACS has a crude system for designating the, head and eye deviations from neutral. So this indicates, 61 indicates that her eyes are turned a little bit to the left and they're down. A couple things I want to offer as warnings for people in your line of work, the pros and cons of FACS for purposes of creating digital faces. And I know there's a lot of text on this. These slides are going to be available with the archived recording of the talk, so you can look at it in more detail later. That, one of the most, important things here is FACS is really valuable as a basis for anatomical instructions for movements, but they're often not used that way. They still are often used as shape indicators, or you've got to look at them as movements to get them the most out of the AUs. Explicit appearance changes in learning FACS are helpful for rendering realistic faces, but some are often overlooked or poorly understood. When we look at I'll demonstrate this when we look at some state-of-the-art digital humans shortly, and you'll see that some aspects of AUs are captured, but not all. And the ones that aren't might be responsible for why we still can get stuck in that uncanny valley. Just to emphasize again, FACS describes movement, not shape. Shapes can be misleading, as can things like furrows. If you take a picture, you see these 2 lines between my brows. Those are called glabellar furrows. I have those all the time. I am not bringing my brows together. That's part of my resting face, but people often infer that I'm bringing my brows together. So the fact that I have these can be misleading about whether I'm doing the action. Another way things can be misleading is, things like lip corners, where the brows are, if they're highly arched. On people's resting faces, they can suggest movement, which is something you can have fun with. If you're trying to make a character look like they're angry all the time, do that. But still, they can mislead you as to what actions occur. One of the things that I think is really important is that studying AUs in isolation is problematic. It leads to poor application. When you're trying to make faces, you need to know how they affect the face. So some things that affect the face, that you would think affect the face just locally, have more distal effects. And let me demonstrate that, since you can see my face right now. If I do action unit 6, which is contracting the outer portions of orbicularis oculi, creating crow's feet. The primary actions are here: creates crow's feet, deepens my infraorbital furrow, lifts the cheeks a little bit, can create the crow's feet and some bulging in the corner. But the other thing that 6 does is watch what this part of my face. This is my nasolabial furrow. Watch what a strong 6 does to my nasolabial furrow. It can pull on and deepen it. So only if you really understand how that contraction works, you would know this. The other thing that's important about studying knowing how all the AUs can work together is that example of the 12-15 smile that I showed on Lena Headey. So if I do it in action at 12 and I add a 15, my lip corners are all 15. 15 wins the tug of war. Zygomatic is pulling this way. Triangularis or depressor anguli oris is going this way. So my lip corners go down, but I can still see that I'm smiling. Why? Because 12 doesn't just bring the lip corners up, it changes this big part of the cheek, which is called the infraorbital triangle, gets lifted obliquely with AU 12. See that? And the cheeks reveal the 12, so that even if I have 15 pulling my lip corners down, I can see the 12 in my cheeks. Okay, and dynamics are really important. And one thing that I can say that is a problem with the heavy reliance on scanning people who are posing AUs is that we know from research on spontaneous emotion versus posed emotion, or spontaneous facial displays versus posed displays, that when people pose action units, there is a very different temporal course for the action unit than when it happens in spontaneous display. The elements of an expression are much more cohesive during spontaneous display. The curve of their onset and offset is smoother. Posed expressions seem to be staggered. So if you're relying on posed expressions for the dynamics of facial expression, you're going to hit a wall with that. Mocap might be better if you're actually getting real dynamic spontaneous displays in the motion capture. And a couple places where I think FACS falls short. FACS does, as many of you probably already discovered, does not describe refined mouth and lip movements of speech. In fact, this is where knowing the origins of the system is really important. That FACS was not designed to deconstruct speech. In fact, when you learn FACS, they give you instructions for how to be able to ignore speech-related movements in the presence of other things on the face. So there are a lot of the movements of speech that FACS captures, but not everything. And the other thing where FACS, I don't know if it falls short, but it falls short for the purposes of creating faces and annotating every frame, is that there's no code for non-action in FACS. When you're not doing anything and your face is in what we might call neutral, like this, the code would be 0. And I have encountered many times in working with people in the digital effects business that they want a code for the mouth, the lips just coming together. This is considered neutral. Although I would say you should have an open mouth neutral and a closed mouth neutral, but this is considered no code. But there's a desire to have a code for that when you're annotating each frame. And some people have misapplied the lip press, which is this, as a mouth closure, which it's not. So there's no mouth closure code in FACS. This bullet point, I already made the point. Some AUs need further unpacking, and there are some missing actions that we're going to be getting to in the revision of the manual. I'd like to quickly go to some state-of-the-art faces and show you how they work. I am going to first pull up a metahuman. Now, we saw a version of this head earlier. I have to share my screen. And we're going to look at Ada here. Now, Ada, if any of you have ever worked, I've just only recently come into contact with the MetaHuman creator. But I'm just highlighting here a couple things. First of all, I want to say this is so impressive. I find these heads very, very convincing, and I'm just can't believe how far the field has come. So by offering this critique, I'm trying to point out where I think that things could be improved, because I know that's what people want to do. They want to make things better. So with that in mind, let's take a look at Ada here, and she's going to be showing, to create these, we just looked at, I'm going to go back to the beginning, some of the little emotion displays they allow in the MetaHuman creator. You can pick different heads, you can pick different lighting, and then there are a number of things that you can do with it. You can do mocap, all this, but there is this way you can work with it and tell this to do certain emotions. And I am going to set aside my critique of whatever the algorithms are for the emotion displays, because I think there are some problems with those, but I want to just look at some of the movements themselves. So let's take a look at her happy display. Now, happy should have AU6, maybe some 7, and then 12, which is zygomatic major, making that classic smile. So just a couple things I'd like to say about what's happening here. That first of all, there's something really wrong with the brow. They're showing the brows flatten in the middle. If there were action unit 6, which should be lifting up here, it is typical for the outer corners of the brows to pull down, and it looks like they're going down, but the flatness of the middle of the brow is problematic. And the thing that's more of a problem, they're trying to convey that she's doing action unit 6, which works right here. But I want to show you in this detailed clip what I see as a problem. And let's see if we captured this right. If you watch this, let's do it again. First of all, no crow's feet. Even in kids up at about at least the surface characteristics are fabulous. They're even having some trace nose wrinkling, which doesn't really fit with this expression right here. Although some people do add a nose wrinkler with their smile, she doesn't have other signs of contracting AU9. So we know that her skin should be capable of surface wrinkling. The absence of any crow's feet here is a problem, because even kids will show some crow's feet with action unit 6. They're implying it with the lifted cheek. Let me go back to the beginning. They're implying the lifted cheek should do an action unit 6. You're seeing a little bit of a bulge, but what happens with 6 is this part comes down, this part comes up, and they meet, and you get folds or bulges right here. Instead, they're conveying most of the constricted eye with action unit 7, which is these innermost rings of orbicularis oculi rather than the outermost rings. Now, even if they don't want to have a 6 be there, and maybe she's not smiling with her eyes, though that certainly is what they're implying, is that she's smiling with her eyes. If we go back to the big Ada happy here, they have her tightening her eyelids instead of constricting the outer portions of orbicularis oculi here. This strong of an AU12 will also create a little bit of wrinkling here, and you don't have to be in your 50s like me to get that. So that the The changes here are inadequate. They're not sufficient to convey what these actions are supposed to be doing. If you had this much contraction zygomatic, there'd be some pushing up here. If you had the brow coming down this much, as you apparently do for the implied AU6, which would mean the smile of enjoyment, the people who created this know that, you would get some signs, some compression, a little bulge in the temple, a hint of a crow's foot wrinkle, but nothing. So that's my critique of this one. Now I'm going to take a look at a different character. We're going to look at Stefan, who is an older male face. And this is just using, I'm showing the emotion of surprise because I was finding weakness in issues with the brows and eyes. And so I want to point out what I see here. So here he is here, and then he's going to do kind of this is the prototypical surprise display, which if we were describing surprise in FACS terms, you would have the lifting of the whole brow with action units 1 and 2, plus some, you see we see more of his eye, right? In his upper eyelid's been lifting it up. We go from seeing all of, almost all of the iris, about 2/3 or 3/4 of his iris, to seeing all of the iris, which implies that his upper eyelid has been lifted. And then he's got the jaw drop and for a classic surprise. Now the problem here, the main problems are with the frontalis and the eyelid. Now let's look at the eye. The eye is a big problem here. The upper eyelid is clearly supposed to be lifted because he is doing an AU5. The problem is they're implying that the brow lift is lifting his eyelid. Why are they implying this? Because his eyelid's relaxed. The eyelid, to expose the eyelid should roll back, and it's not. It's just like that all this stuff is just going up. So we should see, like if I do a 5, you see that the eyelid is opened. The eyelid muscle controls are right here. Frontalis is here. They're two different muscles. So he is not lifting that upper eyelid, even though the amount of eye exposed implies that he's lifting his upper eyelid. So that's one problem. The other problem is with frontalis. They're doing just kind of this, they're capturing about this much of frontalis. Frontalis, when you do a 1+2, which is what these furrows are supposed to imply, he's not just doing 1. This is 1 alone. This is 1+2. The outer portion of the brow should lift up more. And there should be an increase in space between the outer portion of the brow and the eye, and we're not seeing that here. It's just like all the lifting is kind of like going straight up there. So that's my critique of Stefan. All right, let's look at Sukja and this head, and she's going, what are we having here? We're doing her fear display according to the creator. And she has the same problem with her brows that Stefan does, so it's part of how their system works, that most of the action lifting frontalis is kind of in this middle region, and they're ignoring the lateral pull over here. But the thing that strikes me the most is the mouth here. The shape of her mouth implies she's doing action unit 20, which is part of the universal display of the lower face of fear. And if you look at me doing a 20 right now, I need my mirror. I'm putting my mirror right behind my camera. So here's my 20. Notice 20 is a function of rosorius muscle. The rosorius muscle originates on the mandible of the jaw and attaches near the lip corner. It's pretty much a lateral, slightly diagonal action, and it stretches out the lips horizontally. If my mouth were open like hers, it kind of creates this squared off lower lip. It really flattens out the lip and flattens the chin and creates bulges on the sides. With this example right here, we're seeing the mouth shape, but the skin here is not doing anything. The chin is not doing anything. So you just get the change in mouth shape, but you get a little bit of a pull here, but the chin hasn't changed at all. There is a stretching. Remember, even in an older face, you should get some stretching there, so that the deformations there are not correct. And also with a 20, you get a deepening of this lower portion of the nasolabial furrow because the pulling is this way. You're not seeing pulling. You're just seeing the mouth shape change. So in the interest, I have a couple more demos like this, but in the interest of time, I will go away from that. And I would like to leave you. This is text dense. Years ago when, remember a little tip on how to do presentations. Don't put too much text on a slide. Well, I deferred, and I'm deferring to the, I'm thinking more in terms of what you're going to take home with you and have for reference later. So takeaway advice or reminders, don't forget what AUs are. They're the observed effects of muscle contraction. You can learn how muscle contraction looks from the outside by studying the appearance changes of each AU carefully and learning to FACS code. And remembering that the problem of working with AUs in isolation, I've demonstrated that recently, that you need to know how AUs affect one another, as I demonstrated when I showed how putting, having a 12 with a 15, having what look like opposing actions, how they work together, and how an AU localized around a muscle in the upper face can have an effect on the lower face. And apropos, as for the examples that I was just sharing, if you're using AUs to guide your work, be sure that you really understand how they work, how they move flesh as well as skin, how they don't just change the position of features, how you need to use the whole muscle, like these things that even in these really, and I was going to show you some stuff with Ziva, but we ran out of time. The Ziva is another moving head, but how you can have this, they were using not all of the frontalis muscle to show the lifting of the brow and these different emotion displays in those metahumans. They're really compelling, but they're not moving the way the human face does because they were only using part of the action or part of the muscle. So you need to know how they move, how flesh is displaced, what bulges. And really one way of summarizing what it is depth is important, not just surface characteristics. When muscles contract, the fibers bulge. So if I contract my biceps here, it bulges because they're shortening, and they squeeze and they bulge. All the facial muscles bulge as well. So with that, I will officially stop so we have time for questions. I'd like to thank you and thank Bruce again for inviting me. I'm looking forward to a little bit more of an interactive engagement around the questions. Feel free to contact me with questions. Feel free to email me with questions and check out, I have FACS classes you can check out, and they're live classes. I don't teach pre-recorded classes. I only teach live. So if you're interested in any of that, reach out. You can see that there.
Yeah, you were talking about resting neutral faces.
Mm-hmm.
And I have noticed the different characteristics of different people's resting face. Is there an explanation in terms of why certain people do have resting faces that are different from others? For instance, the corners of the mouth you were talking about, like some people, especially in my family, like the corners of the mouths are automatically down in neutral face. So you always get people thinking you're sad or angry or thinking about stuff. But is that because they overwork that muscle, or do you have any explanation for things like that?
Yeah, well, the what controls most of it is genetics. Like, we often look like our parents or one parent, and they can have a certain shaped mouth or a certain shaped brows. So a lot of it is just, what region of the world you come from, what your parents look like. My dad had the downturned mouth. My mom didn't. I got dad's downturned mouth, but that's not to say that use doesn't affect the shape of things, like whether you have a downturned mouth, but use can affect lines, but not completely. Like, if you do one thing a lot like this, I tend to lift my left eyebrow up more, and it is a little higher than my right, which is interesting. And you can't quite tell because of my ring light, but my permanent wrinkles are stronger on that side than they are on my right side. So that the use will affect wrinkling a little bit. Some people say, oh, well, is that why you have that really strong, those two furrows between, because you do all the work with FACS, and is that why you have those furrows between your brow? Because I'm contracting them all the time. And it's possible that plays a role, but just to kind of make it clear, my mother, who's 87, has those lines between her brow like that, and she's not FACS, you know. So there's something that's just, you know, the furrows, the shapes, there's an inherited element and there's a use element, but I don't think use can affect the shape of your mouth. It can affect more like furrows and lines.
Awesome. Thank you so much.
Yeah, you're welcome.
Our next question is Pablo. I'm going to put you on allow to talk. And if you want to come on camera, you can jump on too.
Hi,
Pablo.
nice to meet you. It was amazing. I love your speech.
Oh, good. I'm glad you liked it.
I just wanted to know where we can study, or if there are courses or something.
Yeah. Well, first of all, I always want to say that the FACS manual, which I didn't show the inside of, you can always purchase the manual online and try to study it yourself. The manual is available at Paul Ekman's website. That's the only place it's legally sold. It's a download. So at the very least, begin by getting the manual. And anytime you learn FACS, you should have that. And then I should say that I do teach for years. I've been training people in FACS for over 20 years. I used to do in-person workshops, and I still occasionally do those, but mainly I'm teaching live on Zoom now. And I do have a class that begins in September. So if you're interested in that, please feel free to reach out on my website, erikarosenberg.com. You can find out about that.
I'm about to go speak at EA, and I'm curious about your thoughts on or any experience of the FACS system being tied into things like game engines or predetermined engines or anything like that. I mean, that might be a bigger question outside of this group, but I just a general question for you, you know.
It's being used a lot in game engines. And well, first of all, the one that I was demonstrating, the MetaHuman from Epic Games, that's from their Unreal Engine. And now I don't know how much they use FACS at Epic Games, but most places do use some FACS. You said you're speaking at EA. I've given a number of trainings to EA.
So that's brilliant.
Yeah. And also, I'm actually Chief Scientific Officer at a small company called Humane, which uses a FACS-based rig for character development, primarily for games, and is based on actual scans of me posing every facial action and combination. So there are a number of people out there, you know, in fact, I do a lot of training for people in the digital gaming industry. So I'm always pleased when the people who are doing that work actually choose to learn FACS, because so many come with misconceptions. And that's one of the reasons Bruce invited me, is he said he knows FACS is out there, but a lot of people have misconceptions about what it is. And in my opinion, the only way to really learn how to depict it accurately is to learn how to go through the coding process, which means show me any face, I'll tell you what actions make it up. And it's funny that you say that you're working on face transplants is fascinating. And in a related field, I've had plastic surgeons.
Yeah,
I've learned so much from plastic surgeons and from their dissection, you know, all the stuff that they work with. And a couple times I've had them take my workshops, and it's been really an incredible, it's a bi-directional learning experience, because I learned some nuances of the facial musculature that I didn't know before from plastic surgery. So, wow, good luck with your work. And
thank you.
Yeah, and it's a what an interesting leap you've made, you know, into the medical.
Yeah, and it's sort of just by default. I had one more question, if the group wouldn't mind, or if you wouldn't mind.
Go ahead.
Thank you. Relating to higher fidelity simulation with the FACS underlying, like I was meeting with the Weta Digital team down in New Zealand, and is there any work on or thinking on, you know, as we age, the sort of the weight, if you'd like, of the dermis versus epidermis on facial expression? Is that something that you've looked at or delved in or has come up?
It's come up only informally in my studying of faces across the lifespan, you know, and one thing, as you know, what happens with age is the separation of some of the layers. And but, you know, what's interesting is like I was demonstrating on that model of the older woman's face, you know, that you still, even though the skin is looser on the surface and there's more wrinkles there, you will still see the muscles bulging. You know, in fact, where our, I'm going to show you, since we're informal right now, I'm going to show you a picture of my mother, actually, who'll be 87 next month. And she posed for some faces for me. And
Thanks, Mom.
yeah, thanks, Mom. And but I'm going to just share my screen for a second to show you Mom. And so that's Mom in neutral. See, she's got that. She doesn't do FACS, and she's got the glabellar furrow, and she's doing a 12. You know, she's smiling, but she has a little bit of that 15 pulling down this way. But you still, you know, this whole cheek bulging, you know. I mean, one thing I have going in my favor, I might have this, but if I age like my mom, I'm doing great. She's 80.
I was going to say, I was outstanding.
She's 87, but still, you know, there's nothing going on here that I can't code. And this is the point that I can't emphasize enough. You know, people like, a lot of the work, they've gotten better with even the wrinkling and the textures on the face, but when you contract zygomaticus, this is a huge area that gets lifted and bulged. You got to get this, what they call the apples of the cheek or whatever. This is going to happen. You're going to get the nasolabial furrow deepening. You're going to get this change in shape of the lips. There's nothing about coding any of the actions that I see on her face that I can't do. You know, so I don't know if that's what you're getting at, but there's certainly a change. The skin is, you know, like what I find the most challenging is working with babies, because babies have extra fat pads. They have a fat pad here, they have extra fat pads here, and then they have this incredibly tight elastic skin, so that what we look for feature changes aren't as obvious. And in fact, Harriet Oster, Professor Emeritus at NYU, she developed a baby version of FACS, it's based on FACS, but the appearance changes are different. So like if a baby does AU4, which on me will, you know, bring the brows together and see these lines, they're not going to get the furrows, you know, but you can actually on a baby's face see, as I showed in that one example, the bulges of the contracting muscle under the skin. So that's why I say, don't just know the wrinkles, don't just know the position changes, know how the deformations of the flesh, the bulging in certain regions.
Outstanding. Thank you to you and Bruce for today. It was really amazing.
Oh, good. I'm glad you enjoyed it. Thanks, Andrew, for your questions. And good luck. Have fun at EA. Yeah.
Yeah, thank you. I'll reach out to you. I appreciate it.
Yeah.
Thank you.
I was curious if FACS studies also the subtext or underlining emotional tone. I mean, not just listing like sad or shrugging, but like the you were talking about the corner of the lips, like when you smile, you have the 12, and then some people have that 15. Is there an emotional context that reads through to that? Is that part of the study?
Yeah, I alluded to it. Well, first of all, that's all post-FACS. FACS is just describing the actions and action units, period. And that's the power of it. You know, in terms of psychology, what I didn't get into is that the study of emotion in the face was hindered by people who were just looking for, oh, I think I know what a sad face looks like. I'm looking for sad, I'm looking for happy, I'm looking for this. Whereas FACS decided, let's be objective. Let's see what the face does in emotional situations. So we know from external non-face factors what they're feeling, the situation they're in, what they say they're feeling, what their physiology is doing, and then we can see what the face looks like. So I just have to qualify that FACS is about describing the face. The emotion stuff is what you do with those combinations of codes. That said, we do know stuff from some things from years of research, decades of research on facial expression of emotion, not just these basic emotions like anger, fear, happiness, sadness, disgust, surprise, but we also know what people do in certain situations. Now, I alluded to this when I showed the picture of Cersei Lannister or Lena Headey. I think I say her last name, Headey or Headey, that she often smiles in posed smiles. It doesn't seem to happen as much in spontaneous smiles, which is a whole other area. This smile with the 12, which is zygomaticus, plus a little smile control, this. And we do know from research on self-conscious emotions like embarrassment that when people are embarrassed or self-conscious, they add facial controls to the smile. They try to diminish it. That's not to say that she's conscious of this. That's not people who look around. There are a lot of people who smile that way. And it's something that's either adopted very early in life. It's not the spontaneous emotion of joy, which is more like this, but a lot of people smile like this. And it could be related to self-consciousness or other situational factors that demand diminishing it. Same with this 17. You know, I showed you the Trump smile. I've noticed I've noticed myself doing this when you work with the face for most of your adult life, like I have. You start feeling what you're sending out even when you can't see it. And I've noticed when I like smile, I'm a very friendly person. I smile to people on the sidewalk, you know, like I just walk by them, I smile. I've noticed that I almost automatically go, just put on a quick 17. It's like I'm trying to say, oh, I don't want to be too much, you know. So just to say that that's more elaborate emotional stuff, okay? And in fact, the display of embarrassment itself is different from other emotion displays in that it's a sequence of actions, that it usually involves when we've studied people who have done some sort of embarrassing thing, violated some social norm. What you'll see is they'll kind of turn away, and then you'll see like a smile, and then a quick control, like either a 15 or a 17 or a 24. So they'll do something like they'll smile at themselves and then they'll go, ooh, I'm not supposed to be. It's a diminishing of that. So anyway, I just kind of riffed on what you were asking about, but I don't know if that helps at all.
Yeah, that's exactly what I was curious about. That stuff is the stuff that really interests me, actually. Thank you so much.
Wonderful.
Okay,
Wonderful.
Okay.
Wonderful. Thank you.
Thank you, everyone.
Bye.
For sure. Bye.